All right, welcome. My name is Ryan Holger. I'm with National Excelsior Corporation and Temperature Equipment Corp. I do double duty for both companies, as do several of us. This topic that we're doing this month is on the Gizmo load calculator and energy auditor tools. We're going to spend most of our time on the load calculator, and then towards the end I'm going to jump into the energy auditor and show you how that works. A lot of the stuff in there is very similar, so we can go through it pretty quickly once you have all seen the load calculator tool. This is a web-based tool. I got a couple quick slides I'm going to show you, and then I'm actually going to switch over and I'm going to do the web tool live because that'll be more interesting. So when you log into what we call Gizmo, which is the name of this tool that we have, there's actually 4 different tools built into one. There is one that is used for generating proposals. That's what this tool was originally developed for a few years back. However, we no longer really use it for that. There's other features and other products that we use to generate proposals, so that's kind of been almost like an abandoned thing as part of this tool. However, the other 3 tools were add-ons to it, and those are the ones we use all the time. The first one is Super Sprocket, and I'll show you that real quickly. It's basically a little widget that you add to your website, and your customer, when on your website, can click on it. It says, you know, show me the energy savings at my house, and they'll put in their address, and based on their address, we'll estimate how much energy they might save at their house, generate a little proposal for them, and feed the lead back to you to your email inbox with their contact info. So it's a lead generation tool that you add to your website. I'll show you that real quick at the beginning here since it's really fast. Then there's the load calculator tool, and this is it's basically the same as that Super Sprocket, but it allows you as the dealer to make all the adjustments necessary to accurately calculate their loads. All the methodology of the calculations are based on manual J calculations, but once again, it does begin with the homeowner's address, and we try to guess as much about the house as we can. And then the third tool is the energy auditor tool. This basically does 2 load calculations side by side, one with the current house and the features it currently has, and one with the proposed changes to the house: new furnace, insulation, air sealing, whatever it is that you're doing. As you can see, the side by side, how the loads and the energy usage changes. So I'll try to show you a bunch of these here as we go through. So let me just pull these up on my web browser and you can see them. Could be a little bit easier, you would think. Come on. All right. So you should be able to see my screen now. All right, so you should have a screen that is a website that says Gizmo, icon in the middle, current proposal, list of proposals, etc. Hopefully you guys can all see that. So I'm going to log in, my login. If you do not currently have a login, you can request one. And I probably should show you that real quick. Here are the websites for the tool. Most of you guys are day and night customers, so the website is excelsior.virtualhvac.com. So I will, I'm not cooperating with the screens here today. All right, I will also send this as a link in the chat box so you guys can bookmark it or whatever you want to do. All right, so that's in the chat box so you guys can see that. If you do not currently have a login, Drew Bolsega at our office is the gentleman that you would contact, and then you let him know if you're a day and night, Bryant, or Carrier dealer. I think most of you guys are day and night dealers, being Excelsior customers most of the time. So I'll add Drew's email to the chat box there as well. All right, so then back to our login screen. So I'm going to log in as me. In my case, when I log in, it's actually going to ask me what kind of dealer I am. For you guys, it'll go right to the right page, but I try to do training for everybody, so mine is a little bit different. So here's what it looks like when you basically log in. This right here is the remnants of the old proposal tool. We're no longer using that. In fact, we look down here, there's not even any data available in there, and this is going to go away off the website fairly soon. There are some preferences and things that you can change in here. So under preferences, you can go in and change your contact information, stuff like that, so later on it shows up on your reports correctly, which obviously you would want it to do. But what we're going to click on over here is the Energy Auditor tool. That's what I want to show you guys today. And unfortunately right now, until that website change happens, it actually asks you to log in again. All right. So I logged in again. All right, so here's my basic tool. This is who I am, TEC Ryan, day and night. I have some boxes down here that I can check if I have these particular certifications. So if my technicians are NATE certified, or if I'm a BPI guy or lead or whatever, or ACA member, I can check these various boxes. So in my case, I have it checked for lead and ASHRAE, but obviously you guys are going to have it checked for other stuff depending on what member organizations you are. Then these logos will show up on some of the reports later that we're going to spit out. All right, so over on the right-hand side here, I can look at recent proposals that I have done, if I have any, or I can do a new one. So in most cases, it's probably going to be a new one. And so the basic information you have to enter is the address. So I got one already here. I'm going to enter. So address and zip code. And then if I want, optionally, I could put the information on here for the customer for their contact info so it shows on the reports. I don't need it for the load calc, but if I want to show on the report, I can do that. So I can type those in. I want to put them on here just so it looks good. All right, then I can either hit load calculator or home auditor. The load calculator is going to do a load calculation on this house. Home auditor is what I'm going to show you a little bit later on, that you can propose improvements to the home and it'll tell you the energy savings difference. So I'm going to click on load calculator right now. So I do that and it pops up here with some basic information. Right here is the house. It's this red one here. I can zoom in a little bit better so you can see. So there's the house. Over here is its first guess at what the loads might be. 61,000 BTUs cooling, 88,000 BTUs heating. I live in this house, so I know those loads are a little bit high compared to how I actually operate the house. However, they're probably a little bit lower than what a traditional load calculation might have been. But I have more data I need to put in. Right now, it's just taking its best guess on my address and my address alone. So a couple different things we'll scroll through here. The first one is, the first one here is asking me which side of the house has the most glass on it. So I can pick, north, south, east, west, or the corners. I'd say it has which ones have the most glass. So in reality, this house has the most glass on the northwest side. However, that side of the house is seldom used, so I'm actually going to click on west. And you can see over on the right there, it did change my diversity profile from what the default was, and it did change my cooling load by about 3,000 BTUs. As I click around here and pick different sides, you can see it's changing my load. It's only a little bit. It's a couple thousand BTUs. It's not the biggest difference in the world, but it does have an impact on which side of the house. Then, if I want to, I can go ahead and adjust all the glass size area based on how much glass is actually at this home. In this case, I'm just going to go ahead and leave it alone. You guys understand what that basically means. How many square feet of glass are on the west side, north, south, and east. All right, so you can adjust those pieces of information. In addition to showing me the diversity of how the sun affects the house over here, it also gives me a graph with my loads. So this pink line here is my load calculation for heating. The blue line is cooling, right? And those are the load calculation stays the same for every month. But the actual operating loads you can see are the curved lines. So you can see here heating, 88,000 BTUs is what my load calculation is, but it's probably only going to be operating at 77,000 BTUs because the chance of me getting a -5 degree day or whatever is pretty darn slim. So throughout the year, obviously that changes. And as I get into the summer, the load basically is up to nothing for the most part. And then cooling, it's the same kind of thing. The load gets larger as I go through the seasons. Right? But I'm going to keep tweaking stuff on here and getting this thing more and more accurate here. So in addition to telling it which side the glass is and the square footage, I can click on this house information. It guesstimated the square footage of the home and the age of construction, and it uses the age of construction to guesstimate how leaky the home is and what kind of insulation values the walls have. Plus, I can tweak those things. If it ever comes up with 1,700 square feet, that either means the house is exactly 1,700 square feet, which is fairly rare, or it means that it could not find the particular home. What it's doing is using the Zillow website and tax record type stuff to get the data for the home, the square footage, and age of construction. So this is actually pretty close. This is 2,800 square feet. And it built after 2000. It's like 2003, I think it was. So that's actually pretty accurate. I can put in my utility rates here. So electric, if you guys are ComEd customers, what you want to do with the customer's bills, whether it's this tool or other tools, is you want to take their utility bills, add them up for the whole year, and divide it by the dollars for the whole year. Actually, take the dollars and divide it by the usage, I should say, for the whole year. So whatever it is, $2,000 divided by X amount of kilowatts is going to tell me how many cents per kilowatt that I end up paying. Most people for ComEd customers, when you average it out, are paying about 12 cents in both the summer and the winter time. In my case, I actually am paying 10 cents because I have a third-party supplier that's negotiated pretty well. But for most folks, you would put in 12. Natural gas, on the flip side, is no longer $1.20. It's been a while since we've seen that. At my house, I am currently in the 60-some cent range. Once again, this is all your fees and taxes and everything averaged into the bill. However, if I go back 2-3 years, it was like $1.07. So I kind of split the difference on that, and I usually put in 80 cents a therm. I have no idea what propane is right now, but I'm not going to select propane, but it's probably like $2 a gallon. Oil is probably like $4 a gallon, but I'm not going to pick propane and oil in this example, so it's not going to even matter for this purpose. Design temperatures. So by the default, the summer indoor design temperature is 75, the winter is 70. And those numbers are defaulted that way because that is the way the International Energy Conservation Code is required, that the indoor temperatures be designed for. However, in Illinois, for you guys working in Illinois, we do have an amendment to that code, and we're required by state law to use 72 for the heating number. So if you're in Indiana, Wisconsin, Minnesota, Kansas City, and these places, you'll probably use 70. If you're in Illinois, you'll probably use 72 to appease your permit reviewer. 75 on the cooling side. The outdoor conditions pull the conditions based on the zip code for the facility. So in this case, it pulled 89 degrees for cooling design and 3 degrees for winter design. If I go look at the ASHRAE handbook, for example, and that's what I'm showing you up on the screen here, when I look at heating numbers, I have two different columns I can choose from. I can choose the 99% scenario, so that means 99% of the time I'll be covered with this number, or I can use the 99.6% of the time number. The proper standard care of practice would be to use the 99% number. So this particular house is in Aurora, so that would be 1.4 as my dry bulb design. If I want to be ultra conservative, I would use -2. If you're over near O'Hare Airport, for example, it's pretty similar, 2.2 or -4 for the worst case type scenario. A lot of us in our heads have -10 as a design for Chicago area in our heads. That is not the correct number. It's not even close to the correct number. We almost never get to -10, and when we do, it's an extreme scenario, meaning less than 0.4% of the hours of the year. So if you start, in Illinois anyway, because of the new energy code, if you put -10 as your design in a load calc, you are going to get it kicked back to you, and we have had dealers getting it kicked back since January when the code changed. So make sure you use the correct numbers out of this table. And obviously this table has all the states in it. I'm just showing you Illinois because most of you guys that logged in were Illinois. So for Aurora, 1.4 would be the correct one. And then for the cooling side, the correct column that you would normally use for dry bulb and cooling would be the 1% column, meaning that 99% of the summer hours I'm covered. So for Aurora, 88 degrees. For Chicago O'Hare, 89 degrees. For Chicago Midway, 90 degrees. Right? So you can see some of these ones, St. Louis, 91. So it's basically pulling 89 degrees in that report because that's what it's getting from for Aurora there. When I go back to my load calculator too, that's where these numbers came from, 89, and which was basically rounded off, and 3 degrees, which was rounded off from 2 point something. So those are probably the numbers that your permit reviewer is going to be looking for. So those ones I'm going to leave in here for now. If you guys have questions as we go, type them in the chat box in the bottom right-hand side, and I'll do my best to address them, okay? SHR is the sensible heat ratio. This defaulted to 0.75. Generally speaking, so what I probably should explain what that is. That for the cooling operation, sensible heat ratio of 0.75 means 75% of the equipment load is going to be sensible, and 25% is going to be a latent load. So 0.75 is pretty normal, maybe 0.78, 0.79 for this area of the country. If you're down in Kansas City area, like some of you guys on the call are, it's probably going to be a little bit different ratio that you're going to have, a little bit more humidity, so you might be more like 0.72 or something like that. Number of residents living in the home, this obviously does affect the load calculation slightly. So I will change that to 5. Average ceiling height. This is a 2-story home. It's 9-foot ceilings on the first floor, 8 on the second floor. So average would be 8.5, or roughly. It doesn't make a huge difference on the load calculation. The R values of the walls, floors, and ceilings. So what it's doing here, and the reason it's got these weird numbers like 11.11 and 18.87, based on the age of construction that I told it that I had after 2000, it's taking an educated guess at what that thing was probably built like. However, in this particular house, I upgraded the insulation, so it's actually higher values than this. And since I know that, I'm going to put the correct value in. It's 19 on the walls, and it is 30 on the ceiling. And the floor is basically nothing. It's just carpet type value. So I can change those type of things. Double pane windows is 0.5. That's pretty much what these are. They are slightly better than double pane, but not as good as triple pane. They're double pane argon filled, so 0.45 U value. Solar heat, actually I probably should have left that one that way. I'll leave that one at 0.5 double pane, and I'll lower this one for the low E glass. I can either use the plus and minus arrows, or I can type in 0.6 or 0.5 depending on what I had. So I'll do 0.5. So there's already some defaults for some of the losses of the home, like the duct losses and gains, loss and gains meaning summer and winter, and infiltration rates. I have no idea what the duct losses are on this particular home, so I'm going to leave 10% in there. I probably should get a duct blaster and test it. Infiltration rates, I do know, are significantly lower, more like 0.4. So I will lower those for this discussion. And if I have dedicated ventilation systems, like some of the newer buildings have, or even some 10, 15 years old for code reasons, I can add that ventilation in. So if I got a duct coming in, bringing outside air into the space, I can add that here. So I'm going to do that now. 65 CFM. All right, I could also expand the floor area, and I could change some of those things. Square foot over basement, that's already correct. I don't need to change it. Over conditioned space, none, because it's got a conditioned basement. Temperature of the space is actually conditioned, so I want that to be a lot higher. No slab, so that doesn't really matter. Below grade is the whole thing. R value of the walls in the lower basement is fairly irrelevant because the walls are insulated by dirt, but nonetheless, it's basically 90% below grade. So I looked at some of that information. Now if I want, I can scroll back up here and see how my loads have been affected. So I look at this guy here, and it has adjusted my loads, saying that I need 52,000 cooling, 80,000 heating. And I can see at any given month what the active load would be. I didn't wait for it to finish calculating after that last one, sorry. 42,000 for cooling, 80,000 for heating. So as I'm making all those changes, it's constantly tweaking itself. Now the other thing that I can do if I want to, after I've entered all that stuff, if that doesn't quite jive with what I think this house is, if I have the utility bills for this home, when I do the other tool, the Energy Auditor tool, you'll see that I can adjust it based on those utility costs. All right, but this is just a basic load calculation. It's still calculating here, but we should be close to being done now because this is close to my actual load. All right. What was my last one I changed? Percentage of wall below grade? Okay. All right. So I'm going to leave that alone. It should finish up here with the last one. And then even if it doesn't, when I click on Get Proposal, I'll get my final calculation. I could type in the information here. I'll just leave that stuff the way it is. And then I'll hit Get Proposal. So it's going and finishing that load calculation. It's going to generate it into a PDF document for me to look at. As soon as my really stops. So the problem with a live demo. Does anybody have any questions they want to type in while we're waiting for that guy to calculate? These were the sites that it was on. Do you want to open or save the proposal? I'm just going to go ahead and open it. I could always save it later if I want to as well. So here's the proposal. It's 6 pages. So it gives me some basic information. Where is this place physically located in terms of address and on a map? Square footage, name of the customer, which I just left blank basically. My input values in terms of insulation and how many people live there and that kind of stuff. Leakage rates, so forth. My design conditions for both my indoor and outdoor conditions. This is something that if you're in a state that has an enforceable energy code, such as Illinois, Indiana, Wisconsin, they're policing this stuff, looking to see that you have the numbers that the code matches. So this is something they're looking for, is this design condition page. Make sure you have the right outdoor conditions, make sure you have the right indoor conditions, etc. If I scroll on to the next page, it gives me my load breakdown. So where these loads are coming from, walls, floor, ceiling, infiltration, etc. That way if something doesn't quite look like I was expecting, I can go look and see which one of these numbers is out of whack, which one doesn't seem quite right, if you will. So my heating loads, 81,000 BTUs is my final heating load. And here's my cooling loads. Once again, it breaks it down by the different loads. And then in some cases, like in terms of infiltration air, it gives me sensible and latent because that air would have both of those loads associated with it. Whereas, say, like the wall and ceiling loads would be all sensible because it's just transmission through those materials. So some of them will have breakdowns of sensible versus latent on them. So people's another one. People are both giving off heat as well as sweating into the atmosphere, giving off latent energy. So look at that guy. The total cooling load is 43,000 BTUs. The sensible portion is 37,000. The latent portion is 6,000. So my sensible heat ratio for this particular structure ended up being 0.86, which is fairly low on the latent side, which that is to be expected for a newer construction home because there's significantly less leakage. If you have older houses, you're going to expect to get a more traditional sensible heat ratio of 0.78 or something like that. So that basically comes out to be a 4-ton unit. If I scroll down, I can look at it graphically. Sometimes homeowners like that kind of thing. They can see visually where the losses are. And if you recall, I did not bother punching in the correct square footage of all the glass on the windows, mainly because I was not there to measure them yet. So if I did that, this would all tweak based on that a little bit. And if I scroll down to the next one here, it shows me my diversity based on the hour of the day. And then my equipment selection, which would be used for my manual S calculations, which are also required by Energy Code. So manual J is the load calculation. Manual S is the equipment sizing rules that are required. Both of these are ACCA manuals. So these are my manual J outputs that I would need to use for my manual S equipment selections. So I have to go find a piece of equipment that can do these airflows. So 1,700 CFM of cooling with 37,000 sensible, 6,000 latent, and then also find a furnace or a fan coil that can do 81,000 sensible heating at 1,054 CFM. So I got to go find a piece of equipment that does all of these things. The manual S equipment sizing handbook does allow you to slightly oversize certain pieces of equipment, but it's not very much. For example, on the cooling side, the maximum oversizing according to Manual S, which happens to be Illinois state law, is 15% for sensible and 15% for latent. So you're not legally allowed to put in something that's more than 15% above these two numbers right here that I'm highlighting. On the furnace side, the number is larger. I think it depends on the kind of system you have, but I think you could oversize it as much as like 30 or 40%, I believe it is. But on the cooling side, not very much oversizing is allowed, because the more oversized you are, the worse your latent performance is going to become, and hence you're going to have humidity problems in the home. All right, so that's what that report looks like, and then obviously it's a PDF, so you can go and you can save it somewhere, you can go and print it somewhere to your printer, or both of those type of things. All right, so what did that take us? It took us about 20 minutes or so and that's because I was going through and describing everything as it was happening. As you get faster with this, it's probably going to take you 10, 12 minutes to do a house. As you can see, that this is very applicable to existing construction homes where I know the existing address and the system can go and find tax records for the home. This is not a particular software package you'd likely be using on new construction. It's really for replacement equipment, so replacing furnaces, air conditioners, and stuff like that. If you're doing new construction, you also have to size ductwork and so forth, so you really need a load calculation tool that does room-by-room loads. So this tool is applicable for furnace and AC changeouts. All right. If anybody has any questions, go ahead and type them in the chat box. If not, I'm going to back out of here a little bit, and I'm going to go to the Energy Auditor tool so you can see that. All right, so at the same login, I'm actually going to use the same house example. I probably should have wrote down all the values I put in for the inputs, otherwise I'm never going to get the same answer, but that's okay. All right, so instead of hitting Load Calculator, I'm going to hit Home Auditor. So what this does, like I said, it does the same thing, but it does two load calcs side by side so you can see them both, and you do one with the way the house is currently set up and one with the changes that you're proposing. So the same kind of thing, I'm going to tell it specifically what side of the house has the most glass. I forget what I picked last time. I think I picked west. Robert Dressler is asking how much this program costs. This program is a fantastic price, Robert. It is actually a free program. It does not cost anything. If you are a day and night dealer working with TEC, or excuse me, working with Excelsior, or if you're a Carrier and Bryant dealer working with TEC, we provide this to you as part of your overall dealer package. So if you're day and night Carrier or Bryant dealer working with Excelsior and TEC, this is a free tool. So just let us know and we can set you up with a login. Or you can pay us if you want. That's fine too. I'm just kidding. So I think I picked West last time for the glass exposure. I'll leave those defaults the same. 2,800 square feet is what it pulled up last time, post-2000 construction. Now it's going to ask me some additional questions that I can choose to fill out here. So how do I heat this house? Gas. How do I heat the water? Gas. If it was something else, I could click on that, but it's not. So I'm going to leave that alone. And as you can see, these load calcs are not the same as the last one we just did. Some of the default assumptions are a little bit different on here. But it doesn't really matter because in either case, I want to go through this and make them match what my house is or the house of my customer is. So electricity rates, I'm paying 10 cents, but most ComEd customers are paying 12, so I'll put that in. I'm going to put in 0.8 for the gas. There's no propane here, so that doesn't matter. But just for good measure, I'll put in something fairly accurate. Under the advanced one, I can go ahead and put in stuff regarding the house. Now you see I'm going to have two columns. I'm going to have the house and the spec. The house is the way the house is built today. The spec is what I'm proposing to specify that these folks put in to make improvements to the house. All right, so how many residents? 5. That's not changing unless my wife talks me into more kids. Hopefully not. This electricity usage is not really related to the HVAC usage. This is just general electricity, so lights, computers, and that stuff. For the purpose of this discussion, I want to just focus on HVAC stuff. So I'm just going to put in, well, I guess I'll just put in the same for both, so that way it doesn't matter. So that we won't see energy savings from that because I'm not going to go in and put new light bulbs in for them or whatever. For indoor conditions, 75 for summer, 72 for winter because that's what's required by law. In reality, I keep that much different. I keep my house at 78 and 69, but for code reasons, I'm going to put it like this just so you can see. Actually, I'll just do it the way it is. What the hell? Then I'll know what's really happening. All right. Now, if you want to show some of the effects of putting a better or lower thermostat setting in, you could do it that way. You could do 72 for the current house, 69 for the spec house, and that's going to reflect to them how much energy they're going to save by adjusting their thermostat set point. In this case, I'm just going to leave it like that. Outdoor 89, outdoor 3, those are all fine. I'm going to leave it natural gas. I could keep it natural gas as what I have in the current house now, but I could propose a heat pump or a geothermal system or a dual fuel system or something like that. I'm just going to leave it natural gas. Currently, there's an 80% furnace. Let's say I put in a 97% modulating gas furnace. Hspf is heating seasonal performance factor related to the heat pump. I didn't pick heat pump up here, so this is really irrelevant, so I don't have to do anything with that. COP goes with the heat pump also. Since I didn't pick a heat pump, it doesn't matter. And then the SEER and EER for the cooling system. The current system at this house is 14 SEER. And you can see when I changed the 14 SEER, it adjusted the EER. Technically, there's no direct conversion formula between SEER and EER. EER is straight operating load, and SEER is a seasonally adjusted, so it's seasonal energy efficiency ratio. You can't directly convert between the two, but the software guys basically took their best guess at it, so you can put either one in and it'll adjust the other one. So let's say I was going to put in a slightly better unit, a tax credit unit. Bob asks if Hspf needs to stay the same since we're not improving it. It doesn't have to because I didn't pick the heat pump on here, Bob, but we can make it the same just for the sake of argument. I think 7.7 is a legal minimum heat pump right now, so I'll put that in there just so it all matches up. But it wouldn't have mattered because I didn't pick heat pump for either one of those, so that field is not going to get used. Default sensible heat ratio, 0.75. We already saw from my load calc it's probably something slightly different, so let's just say 0.78. I don't remember what it was. We'll do that. Efficiency loss based on the distribution system. I'm not going to offer any improvements to the homeowner in this particular case. I just want to focus on the furnace example, but if they had ductwork that was in the unconditioned space and you were proposing to seal it and insulate it and stuff like that, then you might have a difference in these guys. In this case, I'm just going to make them both 10% for sake of argument. So they're going to be wiped out, and we're just basically, when I'm done with this for right now, we're just going to have a difference on the furnace. What did I pick? Furnace and AC will be different. Everything else is pretty much going to be the same for both columns for the sake of this discussion. I'll put all the same venting CFMs in. All right. The water heater is natural gas. It is not 6.7. It is, I think, a 0.57 energy factor, which was the legal minimum 10 years ago. And let's say I'm going to put in a high efficiency system, which probably will not be 93%, but if I put in a high efficiency condensing system, actually, you know what, let's do an Energy Star unit. So 6.7 will be a current Energy Star, 6.75, I think it is. Well, that's close enough. The windows I'm going to leave alone. These are actually, I think, 0.45 windows, I believe they are. And I think the glass was 0.5. I should have wrote them down from the other one, but I didn't do that. But it's not going to matter because I'm going to make them both the same. I'm not going to improve the windows in this case. If it was an older home with crappy windows, that might be a different discussion. If I want to insulate and air seal the home itself, I can do that. In this case, I have 19 in the wall, and what did I say, 30 in the ceiling. So I'm going to make those 19 and 30. Actually, I'll make it 19 and 39, which I believe would be current construction. So we'll see a little bit of improvement related to if I added some insulation to the attic, but I'm going to leave the floors and walls alone because it's very difficult to improve those after the fact. What did I put for infiltration? I think I did 0.4 on the other load calc. So we'll kind of try to make that halfway close to the same. So again, as long as I'm not changing in between the two, that won't matter. If I am hooking up a blower door to this house and I take my CFM reading for leakage at 50 pascals of pressure, I can actually put that factor right into here and have it update my infiltration value. So if I put that in here and the volume of the home, which it already knows because I told it, it knows the square foot and I told it the ceiling height, so it actually knows the volume for me. So if I just read the CFM off my blower door gauge, I can punch that in here, then I can hit update and it'll go and correct my infiltration for me. Basement over square feet, that was correct. I'm not making any changes there. It's conditioned, so I'll make that 70. Slab, basement below grade, okay. The one other thing that's on here, if you want to use it, is combustion air zone testing before and after you've gone to the home. This has nothing to do with the energy calculations. It just so happens that most like utility programs and weatherization programs that have some of these energy audit type things also require combustion analysis in the combustion air zone. So they give you a spot here to put all that data in so it'll all show up on one report. All right, so I'm not going to go through that today, but I can do my combustion tests before I do any work, and then I can do it again after I start sealing up the home and the ductwork and all that stuff. So it doesn't have any effect on the energy calcs. It just shows up on the reports later for you. So this is the basic input information that's going to show up on the report. It's going to break down the costs of this house in these color-coded bars. So in this case, this, whatever it is, I don't know, pink or magenta color is the heating costs. This dark blue is the cooling costs. The light blue is the water heating. The yellow was the electric. And then this section down here is basically what we can fix by the improvements I picked. If you recall, the improvements I picked were going from 80 to 97% furnace, going from 14 to 16 SEER air conditioner, and putting a little bit of extra attic insulation to go from R30 to R39, I think I picked. So doing all of those things is going to save me $257. Like I said, this house is only 10 years old, so it's not too bad to begin with. It only costs $2,500 for utility bills. But if you have older houses, it may cost them $2,500 just to heat it, let alone cooling and electricity and lighting and all this other stuff. So $257 doesn't seem like it's a huge dollar amount because this is a fairly new house, but on older houses, you're going to get some pretty eye-staggering numbers for people to look at on here. So they refer to this as heat bleed. Basically, you know, how much is it costing you not to do this stuff? It's costing you $257 a year not to fix those three things we just talked about. Then it gives you the breakdown of the things that we had mentioned. Oh, I forgot the water heater too. I did. Okay. So the heating system, $175 a year, going from 80 to 97% AFUE in this case. The insulation and air sealing, I didn't put any air sealing in my proposal, but I did beef up the attic insulation slightly, $38 a year. The water heater to go from a 0.57 to a 0.67 Energy Star water heater, $31 a year. Cooling system, $12 a year, going from 14 to 16 SEER. Obviously not a big jump there, but if people are in existing houses, they probably don't have a 14 SEER, they probably have an 8 SEER, so the dollars will be a little bit bigger there. I didn't propose any lighting, windows, or ducting improvements, so those all say 0 in this particular case. But had you picked those, they would show up here. Then what you can do if you want is put the costs in for each of these things. I don't have any idea what the costs are, so I'm just going to make up numbers just for sake of argument. Let's say that the new attic insulation cost me $500. And let's say I didn't do that one, didn't do that one, didn't do that one. The heating system, let's say that cost me, I don't know, $4,000 to put the new furnace in. The water heater, let's say it cost me $1,000. And I'm just making up numbers, guys, so don't get mad at me if these aren't what you would normally charge. I didn't pick that one, I didn't pick that one, I didn't pick that one. Where's my cooling system? So the cooling system, let's say it's another $1,500 to change out the condensing unit. So you can see what it's doing there is it's based on the cost, the savings that it has per year, and the cost that I told it's going to cost to install this stuff for the home off of my proposal. It's showing me the savings to investment ratio, and then the number that makes more sense to most people is my return on investment. So the attic insulation is for that amount of savings at that cost is a 7.5% return on investment. The cooling system is a 1% because I didn't make a big improvement there. The heating system is a 4%. The water heating is a 3%. So depending on how good or bad the house is and how good or bad of a proposal of new option you make and how much that option costs you, all those will change here. If this was really $1,000 to do the insulation, I'll click over there. That changes the math over here, right? So how much am I saving? How much does it cost me to get this thing will determine my return on investment. So the best way to explain that return on investment to people is if you didn't put your money into this insulation or into, where's my furnace, into this furnace, wherever you put your money instead, like your bank account or whatever, is it going to give you 4.3% return on investment? Maybe, maybe not, depending on where you're putting your money. If you're putting it in your savings account, it's probably not even 0.5%. If you got some fantastic stock pick, maybe it's better. So this is basically a guaranteed savings, right? Energy efficiency, it's pretty much a lock versus the stock market, which would be a gamble. Then the last section down here before we hit generate proposal on here, the total cost of all the stuff I punched in there was $7,500. It'll be more or less depending on what you're proposing. If there's any rebates associated with that stuff, I can put it in here. So this particular customer is in Aurora, which is the Nightcore service territory. They got $500 right now on a 97% furnace, another $500 in the condensing unit, so that's really a $1,000 rebate. Plus I also have the $500 tax incentive, so that really makes it a $1,500 rebate. So all that's doing is taking that and subtracting it off. So now it's saying it basically cost me $6,000 instead of $7,500 for these things. Once again, I made up the costs, so it's probably not really these are not the right costs. If I'm going to offer these folks a loan, how much is the loan going to be? Well, if they got $6,000 investment, maybe they're putting $1,000 down and they're going to finance $5,000. And then what is the interest rate of the loan and how many months is the loan for? Right, so let's say it's 5 years and we'll just keep 7%. I don't know what the current rates are around these days. All right, so but at 5 years, 7%, financing $5,000. The monthly payment for them is going to be $100. They're going to save $21 a month on utilities. So really, it's kind of like they're paying $77 a month instead of $99 because the utilities are going to offset a little bit of it. All right, and then it gives you kind of the summary here. First year savings over the 7 years, how much is it going to save? So what is the total savings going to be? My rate of return for all these things combined, all those numbers combined up there, ends up being 4%. And then if you want, they can sign it on your iPad or whatever. I can hit Get Proposal over here, and it's going to give me the PDF version of this guy. Oh, that's my one from last time. I don't want that one. That was from the load calc. I want to wait for the new one. All right, so there's the new one. Open. So it's a 6-page proposal. This is what it looks like. Up at the top, it tells you what the total, a year is. If you keep waiting, it's going to cost you $257 more a year to run your house if you don't do the things we just recommended. The basic information about the customer, if I chose to put it in, I didn't do that. My information right here, if I have any affiliations with, any trade organizations or NATE or any of that kind of stuff. And then everything side by side. The left is the current house, the right is the proposed house. So they can see all the stuff I put in. Same. Better ceiling insulation. Same. Here's my loads based on the changes that I made. So a slight tweak in the load calculation there. All right, and then here is the same summaries you just saw a minute ago on that other screen. It's all in the PDF report that you can either save and email to them or you can print and bring to them. And then the financing thing we talked about on the bottom there. And then if you want to see more than that, pages 4, 5, and 6 give you more details about all the inputs that I had put in. What outside air temperatures that I have, what indoor temperatures that I have, right? So I can go look at each one of these things and see where all of them are. Here's all the stuff from my load calculation. So it's really, like I said, it's doing 2 load calculations side by side, showing you the improvements from one to the other. Right, and the load kit didn't change very much because the only thing I really adjusted that affected the load was the attic insulation going from R30 to R39. The furnace and AC choices have no effect on the load, right? They have effect on the overall efficiency and dollars to operate the house, but they have no effect on my load calculation. So my loads are very similar in this case. But if I was doing more home construction improvements, then I would see the differences there. So my cooling, heating load side by side, all that stuff. The sun exposure, which those are almost always going to be the same because you're not going to rotate the house in most cases, so that's not going to really have a change there. So that's what that report looks like. You could then save it, or you can print it off to your printer. I probably should have shown one more other thing on here before I printed that. After I tweaked all these values in here for my insulation and all that stuff, I could come up here again and look at my monthly costs based on the customer's utility bill. So I could take their their March utility bill. Cooling is 0, as you would expect. Heating is $151. If the bill's not really that high, what I can do is I can move these sliders here to get it to be the right number. So if it's really a little bit lower, I can move that. And then this graph, as you could probably see, just moved as well. So now if I look at March, it's 118. If I moved it again, now March is $90, which is a little bit more in line with my March bill will probably be for heating. Same with the cooling side. I can go pick one of the summer bills. June, July, August, if I pick one of those guys, my cooling bill is actually slightly higher than that, right? So I can go in and move those, and it's adjusting the utility costs. And at the same time, it's adjusting my load calculation to make those slightly different. So as I change the utility costs, it's calibrating my load calculation for me to make it more in line with what I'm actually using at this particular house, the way that I operate it. Okay. Does anybody have any questions they want to type in and ask it all? Either the load calculation tool or this energy auditor tool, which is pretty much the same kind of thing. Let me see real quick if I can show you that super sprocket, which kind of goes along with this whole concept. I don't think I have the day and night one bookmarked, but I'll just do this Bryant one. Just don't be mad at me if you're a day and night guy. All right. That's not the one anyway. I don't want that one. What I want is the Super Sprocket for the customer's perspective. All right, so let me put this one up here. All right, so this is part of that same software suite. When you log into that, you can set up some defaults on which systems you want to be your default for the customer, you know, what efficiency systems, and your contact info and where you want the leads emailed to. But your customer, they would come into the website. You basically, on your website, your dealer website, you would put a little link that says, check my home energy bills or something like that, or how can I improve the energy in my home? And they would click on it, and they would come to this screen, and they would punch in their address and their zip code, and then they would click Find My House. And it'll go find their house, which there's that house where we just looked at, and then it would pull up a proposal for them. And they can make a few tweaks, very similar to the load calc and energy audit tools we did, but not as much stuff. They're not going in and putting R values and stuff like that in. They're just basically saying, how old is the construction of the house? What do you heat it with, right? Their contact info, which mine already populated because I did it earlier, but they would punch in their info here and here, so their email and their phone number, which is later on going to be your lead. If they don't punch that information in, this Get Proposal button will not do anything for them. You can see, like we said before, we're getting the information from Zillow. And then what they can do over here is if their utility costs don't match these ones over here, they can move the slide bars once again, and you can see that the costs will get adjusted to whatever they need to be. Right? And they think, oh, okay, that's really what I got. That's how my bills look. Now that they've did that, even though we never put in the R values and everything in the house, by truing up this little prediction with their utility bill, we got a pretty damn good guess at how much it's going to cost them to run their house because we actually have them comparing it to one of their real utility bills. So that's how much we're estimating it's going to cost. There's how much we're saying it's going to cost after we put the new system in. Like I said earlier in a different screen, you as the dealer had set up for all of your customers a default new system. So you probably would put in a 97% furnace and a 16-SEER air conditioner or 18-SEER air conditioner, whatever you wanted. When they come over here and hit Get Proposal, they're going to get a little screen that looks like this that kind of shows them a basic summary, yada, yada, yada. And then if they click Download their report, say Open, it's going to open up a little report for them of a couple pages. And it looks like this, right? So it tells them what unit we based it on. This is not up to date by any means. This is just whatever I had last time I did one of these. It gives the product literature for that guy. So that in conjunction with this page showing them all their heating and cooling breakdowns. And if you looked at the last page, I went back too far. Sorry about that. I should not have gone back so far. Let's do it again one time. All right. So I'm moving their little slide bars to whatever their bill is. Down here showing them visually how much it's going to cost them. And then over here dollar-wise how much they could save. This much cooling, this much heating. Now, don't pay attention to these numbers too much because I didn't go through and fix all these slide bars the way to trim up to a real bill, but that's the idea of it. All right, so let's see. Larry's got a question. The system let you know what, if any, savings they get by a two-stage versus a single stage with both being 97% efficient. Also, what factor if they get an X13 motor. All right, so the first thing is that if a furnace is rated 95% AFUE, it's 95% AFUE. That already takes into account the single versus two-stage versus modulating gas. So those AFUE formulas are already taking that account. AFUE is annual fuel utilization efficiency. It is not a straight combustion or thermal efficiency number. It is already a biased calculation that takes into account cycling losses. So there are more cycling losses with a one-stage than there are with a two-stage than there are with a modulating or three-stage unit. So the AFUE number already takes that into account. So no, it does not do any additional calculations based on the staging. A 95% AFUE single stage and a 95% AFUE two-stage will use the same amount of energy. Now, with that being said, they're going to get more comfort with the two-stage, obviously, and that's the reason to pick the more stages, not the efficiency per se. The X13 motor, that's actually a good point. On the Energy Auditor tool, there is currently not anywhere that I can put in the motor efficiency for the electrical system. It's just not a field that I have editable to me at the current time. So there is a big difference, though, to Larry's point. If I have a PSC blower, it may cost me, let's say, $400 a year to run that motor year-round for heating and cooling and just general air circulation. If I put in a staged ECM motor like the X13 that he is talking about, that might only cost me, let's say for sake of argument, $140 to operate that a year instead of, what did I say, $400? And if I were to go one step further and put a variable speed ECM motor in, maybe it only costs me $80 or $90 a year. So $400 for the PSC, $120, $130 for the X13, $80 or $90 for the variable speed ECM. So there will be some electrical energy savings there. I do not currently have anywhere to change that in the model to account for that. Where are we at here? If I go back to this guy, and I go to my advanced, and you see my side-by-side houses, my equipment down here. Right here, it doesn't take that into account. Now, to some degree, that's taken into account a little bit on the cooling side because SEER numbers for air conditioners do change as you pair them with different motor efficiencies. So on the cooling side, it is taken into account in the SEER number. However, on the heating side, the AFUE number does not take into account the motor efficiency. So for heating and for general recirc, it's not being captured yet in this current tool, and we're working on getting that changed. For cooling and SEER, it is already built into that SEER number. That's a great question, Larry. In fact, I'll make a note to follow up and see what the status is of getting the motor efficiency adjusted in this tool. All right, anybody else have any other questions they want to type in? We're pretty good. All right, well, I thank you guys for logging in today. I do apologize for the time confusion. The next Excelsior webinar topic will be I'm drawing a blank. Let me pull it up because I can't remember what it was. Just do it this way because otherwise I'll forget. I'll pull all the topics up for you guys. All right, so the next topic is, Frigidaire cooling system. So through the wall units, duct-free splits, and stuff like that. And then there's no webinar at the end of May because of the holiday. And then in June is Vent Start thermostats. July is the new utility rebate programs, and so far down the line. So April 22nd will be the next Excelsior webinar on Frigidaire cooling systems. All right, with that, I thank you guys for your time. If you have any other questions, do send me a note and let me know. I will throw up my email real quick in case anybody didn't have it from earlier, and then I'll be logging off here. Thank you.